This is the video for trapezoids and kites. And just real quickly, we're going to go over this quick quiz that you were supposed to take here at the beginning. Give all names that each shape can be using the given information. We look at this first one. Remember, first thing you check, parallelogram. In this case, opposite sides, both pairs of opposite sides are parallel, so it's a parallelogram. The next thing we check is a rectangle. First thing you check is quadrilateral every time, but that's just because it's got four sides. So it is a quadrilateral because it's got four sides. It's a parallelogram, and you should give a reason for each of these. I didn't want you to on the quiz, but on the test, when we take the test over this chapter, you will have to. Parallelogram, and the reason there is because both pairs of opposite sides are congruent. Then we check to see if it's a rectangle. To prove something's a rectangle, easiest way is if it has one right angle. You don't have to prove all four angles are right angles because you already know it's a parallelogram, and we could use that to show that if one of them's a right angle, all of them's a right angle. In this case, we don't know that any of these angles are right angles, so we can't say it's a rectangle. Then you check to see if it's a rhombus. To be a rhombus, the easiest way to prove it's a rhombus, once you know it's a parallelogram, you just have to have two consecutive sides that are congruent. We have that. We actually know all four sides are congruent, so we know this one's a rhombus. And we don't really have to check to see if it's square. If it's a rectangle and a rhombus, then we know it's a square. Well, this one's just a rhombus, so those are the three names that you could give this one. Number two, we had 5 ways to prove something was a parallelogram. Well, one of them said that if one pair of opposite sides are parallel and congruent to each other, then it's a parallelogram. First thing we know, it's a quadrilateral again, because it's got 4 sides. We also know it's a parallelogram because, again, if one pair of opposite sides are parallel and congruent, then it's a parallelogram. To be a rectangle, it would have to have a right angle somewhere, or the diagonals would have to be equal to each other. We don't know that, so we can't say it's a rectangle. To be a rhombus, we don't have enough information to say it's a rhombus, so it can't be a square, so those are the only 2 that we could give to it. Next one. The only thing we know about this shape is it has a right angle in it. Well, just because it has a right angle in it, that doesn't really tell us a whole lot, except for the fact that we can count the 4 sides. So we know it's a quadrilateral. Doesn't work to say it's a parallelogram because we don't know the opposite sides are congruent or opposite sides are parallel or the diagonals bisect each other. Just because it has a right angle doesn't mean it's a rectangle, because first we'd have to know that it was a parallelogram. So the best name we can give that one's a quadrilateral. Next, when we look at this one, we can say it's quadrilateral because it's got 4 sides. So it's got 4 sides, quadrilateral. Same as this first one over here. Opposite sides are congruent, so we know it's a parallelogram. Right here we have a right angle, and again, it only has to have one right angle to be a rectangle once you know it's a parallelogram. So we know it's a rectangle. Next thing we check, see if it's a rhombus. It's got 2 consecutive sides that are congruent, and since it was a parallelogram, that's all you really need is 2 consecutive sides that are congruent. So we know it's a rhombus. Well, if it's both a rectangle and a rhombus, then we know it's also a square. And if they ask you for just the best name to give it, or the most descriptive name in that case would be a square. All right, write down this title, Trapezoids and Kites. What we're going to cover today, be able to use the properties of trapezoids, be able to identify and use trapezoid mid-segment formula, identify if something is an isosceles trapezoid, be able to use the properties of kites, be able to give the best name for any quadrilateral, and this is for the whole chapter, so Could be any of them, squares, rectangles, rhombus, parallelogram, kite, trapezoid, isosceles trapezoid, be able to give the very best, most descriptive name for any four-sided figure. Trapezoid. Trapezoid has two definitions. This first one is the one that the U.S. has used for a long time, and notice it says a trapezoid has exactly one pair of parallel sides. We talked a little about that, where it fits in our chart. The rest of the world uses this, where it says it has at least one pair. So what this is saying, when we say it's just got exactly one pair of parallel sides, then it's just got one pair of parallel sides, exactly one pair of parallel sides, then a trapezoid can't be a parallelogram. All right, the two don't mix together. When we use the second definition and we say it's got at least one, then you check to see if something's a trapezoid. Well, it could still be a parallelogram. So that's the difference in those two. Our book that we have, even though it's a new book, it still uses this definition. A lot of the new books are changing to this second definition. All right, remember, nothing has a symbol except the parallelogram that we did at the very start of this chapter. So we have to write out the word trapezoid, trapezoid, DAB. Remember, you gotta go around it clockwise, or DABC, sorry, or counterclockwise. In a trapezoid, you have these parts. The two parallel sides are called bases. The other two sides are called legs. The angles that surround a base, so that angle for this base up top here, that angle and that angle are called base angles. And then the other two that surround the other base are also called base angles. So you have two pairs of base angles. Those are all the parts of a trapezoid. You just got to know those parts. In all trapezoids, we have a base angle here and a base angle here, but they're base angles that surround the two different bases. These two base angles will always add up to 180. They'll always be supplementary. And these two will always be supplementary. So they're sort of one's on top, one's on bottom. They're from the two different pairs of base angles. One from each different pair of base angles. The ones that are right next to each other. They're actually the ones that surround a leg. So the two angles that surround the leg have to be supplementary. The two angles that surround the other leg have to be supplementary. To be an isosceles trapezoid, same as an isosceles triangle. In an isosceles triangle, we learned that the legs were congruent. Well, in an isosceles trapezoid, you got these two bases. The two parallel sides are called the bases. In isosceles trapezoid, the two legs have to be congruent to each other. The two legs are the same. That's what makes something an isosceles trapezoid. To prove something, if we go back real quick, to prove something is a trapezoid, all we really have to prove is that it's got one pair of sides that are parallel to prove it's just a trapezoid. To prove it's an isosceles trapezoid, there's a couple different ways. And we're going to talk about the properties of an isosceles trapezoid here. But first we'd have to prove it's a trapezoid, so we'd have to prove that two of the sides are parallel. In an isosceles trapezoid, it has a few more properties than the trapezoid does. Still, all those properties for a trapezoid work, but it has its own properties too. In an isosceles trapezoid, these two base angles, two angles that surround one of the bases have to be congruent. The two angles that surround the other base have to be congruent to each other. It's a little different than a parallelogram. Parallelogram, remember, had to be opposite angles congruent to each other. In a trapezoid, it's the angles that surround either one of the two bases. The other thing we know in an isosceles trapezoid is that the diagonals are congruent to each other. The diagonals are the same length. Now the diagonals don't have to be, they don't bisect each other like in a parallelogram, so don't get that confused. And then the third thing, in an isosceles trapezoid, the two legs, which is sort of comes from the definition, the two legs have to be congruent to each other. To prove something is an isosceles trapezoid, we can use any of those three properties to prove it's an isosceles trapezoid. First, you're going to have to prove is a trapezoid. So first you got to prove it's a trapezoid, and you do that by proving one pair of sides are parallel. So if you know one pair of sides are parallel, then you know it's a trapezoid. Then you can prove it's an isosceles trapezoid by any of these three methods. By this one, if you can show that these two angles are congruent, if you can show these two angles are congruent, and these two angles are congruent, then it's got to be an isosceles trapezoid. If you can show that the diagonals are congruent, then it's got to be an isosceles trapezoid. If you can show that the legs are congruent, then it's got to be an isosceles trapezoid. So three different ways to prove something is an isosceles trapezoid. First thing you got to do, prove it's a trapezoid, then just show one of these three things. One of the things that we use a lot with a trapezoid, and doesn't have to be isosceles, just any trapezoid, is a mid-segment. We talked about a mid-segment in a triangle. If you remember a mid-segment in a triangle, mid-segment connected two midpoints. So these two sides those two segments had to be congruent, those two had to be congruent. And if, once we knew that that was a mid-segment, and then we knew that this mid-segment had to be half as long as that third side of the triangle, and it had to be parallel to it. Well, mid-segment in a trapezoid is sort of the same thing. So again, in this triangle, if this side here, if that mid-segment was 7, then we know that that third side would have to be 14. Sort of the same thing in a trapezoid. We know that if M here is a midpoint, S is a midpoint, this is called a mid-segment. If that's a mid-segment, then we know that all three of these, the two bases and that mid-segment, are all three parallel to each other, and we know this formula right here. We add this base plus this base, divide by 2, and that gives us the length of the mid-segment. So if I told you the top base was 10, the bottom base was 20, you just add those two, 10 plus 20, divide that by 2, you get 30 divided by 2, which is 15. That means the length of that mid-segment right there has to be 15. Now, if you sort of use that formula backwards, let's say we know that this top one is 7, the mid-segment is 12, and we're looking for this other side over here. You can use your brain and just sort of think it through, or you could actually use the formula and plug in 12 here for the mid-segment, 7 for one of the bases, x for the other base, divide that by 2, and solve that formula. Or you could just sort of think it through if you look at it and know that normally you add, then divide by 2. Well, if you take the top base here, or the base that you know, multiply it by 2. I'm sorry, I said take the top base. I meant take the mid-segment, multiply it by 2, then subtract the other base, and that would give you the answer. So if we take this mid-segment, multiply it by 2, that's 24. 24 subtract off 7 is 17. That means this side down here has to be 17, and you can sort of check your answer to make sure just by adding these two and dividing by 2. 17 plus 7 is 24. 24 divided by 2 is 12. So that would be the third side. And you just sort of think it through. Or you can use the formula, whichever way is the easiest for you. For a kite, for something to be a kite, 2 pairs of consecutive sides have to be congruent. Consecutive sides, sides that are hooked together, sides that are right next to each other. Notice all the sides can't be congruent. If all the sides were congruent, then it'd be a rhombus or a square. So if we know that these 2 sides are congruent, we know that these 2 sides are congruent, then we know it's a kite. Notice when you have a kite, these top 2, you can sort of separate them off from the bottom 2 congruent sides. Another property of a kite, one pair of opposite sides are one pair of opposite angles are congruent. This is another property. So in a kite, we look at this kite, these 2 angles don't look like they're congruent. It's the 2 angles where you would separate them if you were pulling the kite apart and have 2 congruent sides on one side and 2 congruent sides on the other side. So that angle has to be congruent to that angle. Next property. Oops, let's go back. So that angle has to be congruent to that angle. Next thing, diagonals are always perpendicular to each other. In a square, the diagonals come together to form right angles. In a kite, the diagonals come together to form a right angles. In a rhombus, they also come together to form a right angle. So all 3 of those shapes have that same property. So that's one of the diagonals. That's the other diagonals. And we know all the angles there where M are, all these angles are going to be right angles. Next, one diagonal bisects the other one. Only one of them bisects the other one. In a parallelogram, the diagonals bisect each other. In this one, only one of them bisects. And if we look at this, segment TM doesn't look to be the same length as segment MS because they're not in a kite. But the other 2, NM and MH, look like they are equal. And those are the 2 that have to be congruent to each other. One of the diagonals bisects the 2 angles. Notice here, these 2 angles don't look the same, these 2 angles don't look the same. But these 2, if I could draw a little better, and these 2 are the same. So this one diagonal, just like in a rhombus, the diagonals bisect the angles. In a kite, the diagonals bisect one pair of opposite angles. Not both pairs, but one pair. So we know that that angle is congruent to that angle. We know that that angle is congruent to that angle. So all these properties are all properties of a kite. All things you know if you know something is a kite. Kite's a little harder because if you turn the kite around, it changes the way everything is set up. And then you got to know which ones. Know that these 2 angles are going to be congruent. And know that this diagonal is going to bisect those 2 angles. All right, in our chart here, remember to use this chart, you're just going to start here at the top, and you're always, when it's asked you to give the best or most descriptive name for a shape, you're just going to go through this whole chart. To show something's a quadrilateral, that's always the first thing we're going to do. Well, the only thing that has to be true for it to be a quadrilateral is it has to have 4 sides. To be a parallelogram, easiest way to prove something's a parallelogram is by showing that both pairs of opposite sides, I should probably put both pairs of opposite sides are parallel. If something's not a parallelogram, then it could be a trapezoid. So we check that, and to be a trapezoid, one pair of parallel sides. If you can show one pair of sides are parallel, then it's a trapezoid. If it is a parallelogram, we don't just stop there, we check, see if it's a rectangle. Easiest way to check, see if it's a rectangle, once you know it's a parallelogram, it just has to have one right angle, But what we usually say about rectangles is it has 4 right angles. That's just a key property. But if we were trying to prove it's a rectangle, and we already know it's a parallelogram, then you just show one of the angles as a right angle, and then you'll be able to figure out all the rest of them have to be right angles because it is a parallelogram. And in a parallelogram, you know opposite angles are congruent and consecutive angles are supplementary, so on, so on, so on. Once we know if it's a rectangle or not, we still got to check, see if it's a rhombus. To be a rhombus, if we were trying to prove it's a rhombus and we already know it's a parallelogram, then you just say one pair of consecutive sides are congruent, then you'll know it's a rhombus because we already know it's a parallelogram. But the key property for a rhombus is 4 congruent sides. 4 congruent sides. But if you already know it's a parallelogram, you know opposite sides have to be congruent to each other. To check, see if something's a square, all we do is we have already checked, see if it's a rectangle. We've already checked, see if it's a rhombus. If it's both of them, if it's both a rhombus and a rectangle, then we call it a square. If it's only one or the other, then we can't call it a square. If we checked up here and it wasn't a parallelogram, we checked and it wasn't a trapezoid, then the other name we could give it is a kite. Remember, the key property for a kite is 2 pairs of consecutive congruent sides. So if you can show that a 4-sided figure has these 2 sides congruent, those 2 sides congruent, then you know it is a kite. Right, on the worksheet. On the worksheet, look at number 1. We look at this first shape. We know that those 2 are parallel. So since we have one pair of parallel sides, it tells us it's a trapezoid. We also know that since these 2 are congruent, those are the other sides that are not the parallel sides. So those are the legs. So it's got to be an isosceles trapezoid. And an isosceles trapezoid, or actually in any trapezoid, doesn't matter if it's isosceles or not, these 2 angles that surround one of the legs have to add up to 180. They have to be supplementary. So to find x, all we got to do is take 180 minus 94. We borrow here, end up with 6, make that a 7. Have to borrow again, make that 17, 86. So x equals 86 degrees. X equals 86 degrees. The second one, we look at this, these 2 sides are congruent, these 2 sides are congruent. Well, it's not a parallelogram because opposite sides are not congruent, but it's a kite. Since we know it's a kite, in a kite, we know some properties. These 2 angles, where you separate the 2 pairs of congruent sides, those 2 angles always have to be the same. So if that angle is 100, this angle down here has to be 100. And we also know that since it's a 4-sided figure, all 4 interior angles have to add up to be 360 degrees. Remember, that works for any 4-sided figure. So if we add all these up, set up an equation, we get 100 plus 100 plus 90. So this angle plus this angle plus this angle plus the 4th angle, which is x, should equal 360. Be able to set up that equation. 100 plus 100 plus 90 is 290. So 290 plus x should equal 360. We subtract 290 on both sides and you end up with x equals 70. So x equals 70 degrees. That's for number 2. Number 3. On number 3, you know that this is a trapezoid. And this segment right here is the mid segment. Because we know that these two are congruent, we know that these two are congruent. So if that's a mid segment, we use the mid segment formula, where the mid segment should equal the two bases added together divided by 2. So 12 plus 22, and we're going to divide that by 2. Just grab your calculator. 12 plus 22 is 34. 34 divided by 2 is 17. So x right there has to equal 17. That mid segment has to be 17. Next one. We look at this, these two are congruent, those two are congruent, so again, we know it is a kite. It's not a parallelogram, it's not a trapezoid, it's a kite. And a kite, we know that those two angles have to be the same, so if that one's 2x, this one has to be 2x. And again, just like on the one right above it, we set up an equation. We know all four angles have to add up to be 360 degrees. So x plus 2x plus 2x plus 55, that's all four angles, should add up to equal the total, which is 360 degrees for a four-sided figure. Collect like terms, you end up with 5x plus 55 equals 360. Subtract 55 on both sides, you end up with 5x equals 305. And then divide both sides by 5, and you end up with x equals, 5 will go into 36, into 30 6 times. 5 will go into 1, or 5 will go into 5 1 time, so 61. So x equals 61 on that. 5 through 8, give the most specific name for each quadrilateral, explain your reasoning. We look at this first one. Since it's got four sides, we know it's quadrilateral. Then we look at opposite sides. Well, opposite sides, both pairs of opposite sides are congruent to each other, so we know it's a parallelogram. Then we can check, see if it's a rectangle. We don't know anything about the angle, so we don't know if it has a right angle or not, so we can't say if it's a rectangle. Then we check, see if it's a rhombus. This side and this side, actually all four sides are congruent, but if it's a parallelogram and one pair of consecutive sides are congruent, then it's got to be a rhombus, so the best name we can give this one is a rhombus. Next one, we look at this next one, number 6. On number 6, we know these two sides are congruent, these two sides are congruent. Well, those aren't opposite sides, those are consecutive sides. So we can't say it's a parallelogram, so we check, see if it's a trapezoid or a kite, and this one is a kite, so that's the best name we can give to it. Next one, we look at this, we got one pair of parallel sides. As soon as you know you have one pair of parallel sides, then you know it's a trapezoid. And our reason there would be if it has one pair of parallel sides, then it must be a trapezoid. And I should have wrote the reasons on these others back here. Let's go back to the kite for this. Two pairs of consecutive congruent sides. That would be your reason for that one being a kite. To be a trapezoid, we know this is a trapezoid because it's got one pair of parallel sides. Got to be able to write this stuff out on the test and explain it. One pair of parallel sides. Once we know we have one pair of parallel sides, the other thing we can check to see if it's an isosceles trapezoid. To be an isosceles trapezoid, these two sides have to be congruent. We don't know that, but we do know that these two angles are congruent and they surround this base. Well, if those two angles are congruent, then that tells us these two angles up top here also have to be congruent, because these two must add up to be 180, these two must add up to be 180. So to add up to 180, these top two have to be the same. Well, if that's the case, if these two angles are congruent and these two angles are congruent and it's a trapezoid, a better name for it is an isosceles trapezoid. And our reason would be it's got one pair of parallel sides and base angles are congruent. and the base angles are congruent, so we know it has to be an isosceles trapezoid. Number 8, we look at number 8, you know these two sides are congruent, you know these two sides are congruent. The best name we can give it is a kite. And our reason, because it's got two pairs of consecutive congruent sides. It's got two pairs of consecutive congruent sides. That's what makes it a kite. On the next one, which is supposed to be labeled number 9, take a second, graph it. When you do graph it, that's what it should look like. So we got this quadrilateral here, ABCD, and it says find the length of the mid segment of the trapezoid given the vertices. So we actually know it's a trapezoid, so trapezoid ABCD. All right, sorry I messed up, erased it. So we got this trapezoid ABCD. They want us to find the length of the mid segment. To find the length of the mid segment, we're going to find, we got to find the midpoints of the legs. This is one of the legs. So we're going to find the length of that. Remember the midpoint formula is you add the x's together, divide by 2, add the y's together, divide by 2. So to find the midpoint of segment AB here, we're going to add the x's, divide by 2, add the y's, divide by 2. If you look back at your paper for A and B, the x's are 0 and 4, so 0 plus 4 divided by 2. The y's are 3 and 5, so 3 plus 5 divided by 2. And we just do that math there. 0 plus 4 is 4, 4 divided by 2 is 2. 3 plus 5 is 8, 8 divided by 2 is 4. So we go over 2, up 1, 2, 3, 4. And that point right there is going to be the midpoint of segment AB. That's our 2, 4 right there. Then we want to find the midpoint of segment CD. You probably could have about figured this problem out without doing all this, but because of the way the segments, some of them are vertical. These two segments are vertical, and we could have figured it out other ways, but I'm just doing it out the long way. I'm not going to actually use the midpoint formula in this. I'm just going to look at it, and I know this is a horizontal segment. Well, to be in the middle, if I count the whole thing, 1, 2, 3, 4, it's over 4 spaces, so the midpoint would be over 2 spaces, which is right there. That segment is the mid segment. Ignore that extra part that went out there. That's the mid segment. And what we want is we want to find the length of that. Well, normally to find the length of that, we would use the distance formula. Subtract the x's, square it, subtract the y's, square that answer, and add those two together, then take the square root of all of it. This time we don't have to because this is a vertical segment, and all we really got to do is count. 1, 2, 3, 4, 5, 6. So the length of that mid segment is 6 units. Whatever it happens, whatever the units happen to be, it's 6 units long. We could have done the same thing. We could have counted the length of this base and got 1, 2, 3, 4, 5. Length of this base, 1, 2, 3, 4, 5, 6, 7. And we could have used the mid segment formula, which is the two bases added together divided by 2. 5 plus 7 is 12. 12 divided by 2 is 6. We would have got the same answer either way. But that only works since we have those vertical and horizontal segments in this picture. Number 10, they want us to decide whether this is a trapezoid or not. Easiest way to decide if it's a trapezoid, graph it, look at it, and it looks like that these two sides are parallel to each other, and it looks like these two sides are not parallel. So I'm going to find the slope of segment UT. Remember, to find the slope of a segment, you just do rise over run when you're on a graph. And if these two are parallel, their slopes should be the same. Well, I noticed that my rise is 1, 2, 3, 4, 5, and my run is 0. Well, you can't divide by 0, so this one actually has no slope. I look at the other segment that should be parallel to, VW. and I find the slope of it, the rise is 1, 2, 3, 4, 5, 6, 7, it goes up 7. And the run is 0, well you can't divide by 0, so that has no slope. And if those slopes are the same, then we know that those two segments have to be parallel to each other. So if these two are parallel, then we know it has to be a trapezoid. We could check the other two sides, UV and TW, to see if they're parallel or not by finding their slopes, just to make sure it's a trapezoid and not a parallelogram. But I'm just going to tell you that it's not a parallelogram. So right now we know it's a trapezoid. So is trapezoid. So we know it's a trapezoid. They also ask us to tell or decide whether it's an isosceles trapezoid. For it to be an isosceles trapezoid, segment UV and segment TW have to be the same length. So I'm going to find the length of segment UV by using the distance formula. In the distance formula, you set it up, look at U and V, and we take our x's. Our x's are -1 minus, for V, the x coordinate is 3 squared, plus the y's for U and V are 3 minus 4, and we square that. Do the math, make sure you're doing the math correctly. -1 minus 3 is -4. -4 squared is 16, positive 16, plus 3 minus 4 is -1, -1 squared is 1, 16 plus 1 is 17. We could take the square root of that. It comes out to be about 4.1. You didn't really have to, because all you're trying to do is show that the other segment is the same length. So we take the other segment, which is TW, and we're going to do the same distance formula for it. I'm probably going to do it a little quicker this time. For T and W, our x's are -1 minus W is 3. For the x, the y's are, for T and W, are -2 and -3, so -2 minus a -3 squared. Remember, when you have a minus a negative, that's going to change to plus there. -1 minus 3 is -4. -4 squared is 16. -2 plus 3 is 1. 1 squared is 1. 16 plus 1 is 17. And we know that that's 4.1 then. Well, these two are the same. And since they're the same, we know it is an isosceles trapezoid. And our reason there would be because the two legs are the same length, or are congruent.